Okay, so today what we're going to do is we're going to talk about atoms. We're going to review over your notes from yesterday, from your Cornell notes of page 255 to pages 258. Okay, so basically it starts like a story. And what we're talking about is imagining you found a gold nugget while you're panning for gold in Colorado, okay? Must have been a really big gold nugget, according to this picture anyway. And you decide to share your prize with family and friends by having it cut into smaller pieces, okay? Using a special tool, you cut the nugget in half and then in half again, over and over again, and eventually you're going to end up with a piece of gold that is too small for you to cut with the tool that you have. Okay, so what kind of change is this happening right here? From here to here. We cut it in half, it becomes smaller, we cut those in half, cut those in half. What kind of change, Ryan? Physical change. It didn't go gold, 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 mustard. Okay, it's still gold no matter how many times we cut it in half. Okay, so the question is, you've got a lot of family and friends. So suppose that you were able to keep cutting the gold into smaller and smaller pieces. Would you be able to be cutting forever? No, absolutely not. At some point, you would end up with a piece that could not be divided, and that smallest piece would be called the atom. Now, one of the things that you picked up today when you came in the room was the periodic table of elements, okay? So let's take a look at finding gold, okay? Look for gold. I want you to look for gold. Demetrius, which number are we? 79. Okay, all of the elements or all of the atoms that are found on the periodic table are all of these elements in its purest form. So when we're looking at gold, okay, that means that the only thing inside this element right here is gold. And that's what we call an element, okay? So an atom is the smallest particle in which an element, such as gold, can be divided and still maintain properties of that atom. Sorry, it's kind of hard to see because of my little recording thing. Of that element. Because all matter is made up of elements and all elements are made up of atoms. So therefore, atoms are considered the building blocks of matter. Now, do you see in the periodic table, we've got all of these things and they're set up in a way where it's easy to understand and it's organized in a way that we're going to talk about in a few minutes. Okay, so the atoms are considered the building blocks of matter because they make up everything. Okay, because I think we had a conversation prior about, are atoms matter? Yes, they are, because they make up matter. So of course they are. So we're going to look at the second page, which is atomic structure. And how many people find these two words kind of scary? Yeah, okay. It's really not that bad. What does atomic mean? What does atomic mean? Look at the screen. What does atomic mean? Atom, okay. What does the word structure mean? Structure, or how you build something, right? So basically atomic structure is atom model. Are you still scared? You shouldn't be. This is the easy part. Okay, atoms are made up of even smaller particles called protons, neutrons, and electrons. Protons and neutrons stick together to form an atom's nucleus. This is our drawing right here. You should have something similar to this in your notes, so hopefully you drew it. Which at the center of the nucleus is found at the center of the atom, just like in a cell, right? The nucleus is found in the middle. Okay, let's talk about the first part, which is the proton. Protons are the positively charged particles in the nucleus of an atom. Okay, protons are positive. I drew a little positive sign there, so I knew, because remember, I'm allowed to write in my copy, but you're not allowed to write in your copy. You're allowed to write in your notes. And then the neutron is, what's the charge of a neutron? Chloe. Neutral, so I put a 0 because it means no charge. Okay, so we have positive protons, neutral neutrons. Okay, what else do we have in the atom? What else do we have in the atom? Marissa. Electrons. And what is the, I have to turn it sideways so that it fits. I'm having issues with the Elmo today. I can't get my bearings at all. Electrons are what kind of charge? Negative. So I wrote a little negative sign next to my electrons. So here's how it works. It's like a love triangle because I try to explain things to you guys that you in a way that you would understand, because sometimes when something is so abstract, it's kind of hard for you guys to grasp on it. But boys and girls are something that you guys can relate to, right? And drama. Okay, so this is kind of the nice guy finished last story. Okay, so you've got on the inside, we've got this, what is this part right here that I'm pointing to? Not all of it. This part right here. The nucleus. Okay, so this is the nucleus. And who's hanging out in the nucleus? The protons, which are the girls. Okay, the girls are the protons because they're like, I love everybody. I want to be in love because that's what girls want to do. And then you've got neutrons, which are like, this is like the guy that every good guy hates because he's the like, I don't care. You know which guy I'm talking about, right? The guy that's like, the girl's like, want to go to a movie? I don't care. You know, like that, you know what I'm talking about? Okay, neutron is neutral because he doesn't care about anything. And so he just kind of hangs out, except himself. Sorry, boys. So they're hanging out, and then you've got the electrons, and the electrons are the good boys. Even though they're negative, they're attracted to the positive because the good guy wants to be with the good girl, but the good girl wants to be with, I don't care. Okay, so it's a constant, one of those constant love triangle relationships. Okay, what happens when you put positive and positive together? Positive magnet together, what happens? They repel. Okay, what happens when you put positive and negative together? They attract. So it makes sense that the positive, the negative electron would be attracted to the positive proton, right? Unfortunately, the proton is saying, sorry, you can't come in. Because the girls are like, I want to hang out with the whatever guy. Whatever guy's awesome. I love whatever guy. And then good guy's like, I hate you. So, but I still want to hang out with you because I'm in love with you. Okay, so does that make sense to you guys? So this is the nucleus of the atom, and then you've got the electrons swarming around. So it's kind of like the nucleus is the beehive, and the electrons are trying to get in. They're the bees. Okay? Does that help you? Okay, good. All right, so let's talk a little bit more. We already did that part. Okay, so now we're going to talk about how the electrons behave, because they behave kind of erratically, because that's what good people do sometimes when they're blinded by love. They're like, oh, I love you, and then they do really dumb things. Yeah. Who was that? Nick's like, I've done that. I've done that too. So don't worry about it. Like, you think it's like the best idea at the time, but really it's not. Okay? Don't act on your first impulse when you're in love, because love blinds you. Okay? All right. Scientists used to think that, who knew that science would also be the love connection? You guys could get lifelong advice in here, right? Okay, scientists, I love the hands up in the air. Scientists used to think that electrons orbited around the nucleus in a fixed path, okay? And they said they can only go this one way all the time, and they can't go anywhere else. But now they theorize that electrons actually travel in random paths all over the place, which is kind of like a teenager, because teenagers are like, wee, I love life, and I'm invincible, but not really. Okay, and then the electron's energy level determines its average distance from the nucleus. We're going to talk a little bit about that when we get into atomic theory. It'll make a little bit more sense, because I know right now it's like, what? I don't get that. All right, so this paragraph right here was just basically telling you that protons are positive, electrons are negative, and they like each other. But it's all this wording. So that's kind of confusing, so we're just going to skip that part. All right. Atomic size. Now, we know atoms are tiny, right? Okay, we know they're small, but just how small? And that's what I want you guys to understand. Behind Nick's going to be my visual aid person right now. He's going to hold up a meter stick for me, please. All right, so a typical atom is about 1/billionth the size of that meter stick. 1/billionth size smaller. Okay, the proton, or the nucleus inside of the atom, is 1/millionth billionth times smaller than that meter stick. It's smaller, smaller. So the nucleus is itty bitty. Okay? So you had to tell me, what is the nucleus? That was weak. You have to be loud but squeaky at the same time. The nucleus was? Awesome. Okay. So it's a tiny fraction of the size. Thank you, Nick. You're being Vanna White today. The protons and the neutrons that make up the nucleus of an atom have about the same mass. Okay? So the largest part of an atom is the proton. The largest part of the atom is the proton. Did you write it down? The largest part of the atom is the proton. Now, the neutrons, they like to hang out with the protons because, remember, it's the I don't care. It's the I don't care guy. Oh, I love you. I don't care. I love you. I don't care. Okay, so that's the relationship that's happening in there. The neutron is about the same size as the proton, but it's a little bit smaller. So the proton is the biggest part. The neutron is the middle part, which is like almost the same size as a proton. And the smallest part is the electron. Okay, the electron is the tiniest part of the atom. Okay, now the particles that make up an atom are basically tiny specks. So if you were an atom, an electron would be a speck of dust compared to your size. Does that make sense? So you're the big atom, and a speck of dust is the size of the electron. Crazy, right? But it's like way, itty bitty. Okay, it's small. Okay, the majority of an atom's volume consists mostly of empty space. Okay, so the volume of an atom is mostly empty space. Say that you want to write that down too. Most of the atom is empty space. And they're itty bitty. Itty bitty. Okay. And that is all you need to know about the actual atom. Not that hard, right? Okay, good.